The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone. It's 1 minute to go until broadcast time. I just figured I would poke in and say hello. Let's go ahead and share my screen. Looks like some people are still joining, so we'll give it just another 10 or 15 seconds and then we'll get fired off here. So this afternoon's presentation will be about TopSolid'Cam. Again, this is a big picture overview, and we're going to go through some really cool key features as well as some new products that are available relative to the CAM product offering. Okay, it's 1 o'clock officially, so let's get started. Okay, so this presentation is going to be broken into 6 main sections, and each section has, lots of details to it. Okay, so without further ado, let's get started. We're going to start talking about boost machining to begin with. Okay, so I'm going to start here, talk about the modules. So there's 2 modules available this year now. There's Boostmilling and there is BoostTurning. Boostmilling is module 3022 for those of you keeping track of module numbers. It is the extension for TopSolid'Cam's Boostmilling. That module will open up functionality based on the level of machining that you guys have. So if you have boost on top of 2D milling, you'll have boost options in 2D milling only. If you have boost on top of 2D and 3D milling, you'll have boost options in 2D and 3D milling, and so forth. This year we have also incorporated BoostTurning. It's another module by itself, and it's available in the roughing algorithm for like groove roughing, and we'll see that here in a moment. Now, let's talk about what's new. So in 2D milling, we have added the ability to have a custom coolant during the plunge. This improves cutting. So maybe you want to have a through coolant on the plunge and then flood on everything else, so go crazy. We've integrated contouring, or I should say integrated contouring is now managed inside of Boostmilling. Again, improves accuracy of the cuts. The mixed milling direction available is in Boost now, so you can both climb and conventional to help avoid any type of rapids. This saves some time on the machine. And then you now have a new adjustable toolpath smoothing level. Allows you to better manage the movement on the machine dynamics, optimizes the toolpath. Later this week when we go into our deep dive into CAM, we'll get into how the smoothing actually operates and some of the other new controls. If we look at some of the improvements here, the boost milling algorithm is integrated within the roughing finishing operation now in 3D. In 4D, the boost milling algorithm has been integrated in end milling and in 4-axis radial roughing. So if you do a lot of 4-axis continuous roughing, you will now have the ability to use the boost algorithm in it. As I said, it is now available in turning as well. And then there is also some tools. If you're converting from volume mill or volume turn to boost, there's some tools available to help with that conversion. All right, so let's have a couple of quick samples here. First of all, with boost milling, just to understand the concept of what it is, there's a couple of things to really look at. Anytime the software is working in a tight area like this, it's using a trapezoid style machining in order to minimize overloading the cut. Anytime we can, we work with concentric circles. Okay. Here, when we're starting from the open pocket, it's doing a spiral to kind of open up the area so that we can get into roughing everything in a clean way. As the toolpath gets into the corners, you can see it trapezoids to go into the corners as well. The thing to remember about boost milling is it allows both dynamic control of the feed rate and the thickness of the chip. So the feed rate's varying, the chip thickness, you have the ability to control how that varies as well. All in all, the boost algorithm should give you great control over material removal. Again, just taking a quick look inside of the boost strategy here. You're avoiding overloads here as we're chicoiding in through the slot areas. Instead of doing a full circle in the background, it's just doing a small arc off, coming over, back arc on, and continuing into the cut, nibbling, nibbling, nibbling. Okay. Again, I think I talked about this in the big image. Dynamic corners are controls of the advanced thickness of the chip. The tool is never overloaded. You can see again as we get into the corners, it stops and it kind of nibbles its way in. Okay. And then when we can have optimal machining conditions, the software just does a great job of keeping things simple. So here we have parallel straight lines just to show you case that, hey, you know what? We know we can just do fast moves straight through these areas. Or in the case where there's curvature, we're doing simple concentric circles here. Again, keeping that engagement exactly perfect. The same concepts are used in BoostTurn. The difference is you're using a turning tool, not a milling tool. It's still going to keep things consistent as far as load is concerned. It's still going to chicoid into corners to help minimize chip load. And of course, you still have the tangent in, tangent out, just to keep the machine motion as smooth as possible. So in the boost strategy, whether you're milling or turning, it calculates tool path in accordance with these conditions. And basically the goal is to keep that machine running smoothly, not jumping all over the place. So here we can take our first look at a video. So this is the boost turn algorithm, and you can see it's just nibbling its way in there. You can see the speeds and feeds and depth of cuts that were set for this thing. And it's just going in a nice, smooth, continual motion. And it's just advancing that material out of there very quickly. Now, if we look at this next one, and you can kind of see that arc retract and entry. So again, keeping that motion smooth. And when we're going across, you can see it's just keeping a nice, simple linear distance, or linear move, I should say. Then here we nibble out the corner. We can have a look at what that looks like from outside a bit. Nice. So that's boost turning. Now, let's continue on. The next main topic we're going to speak about is some module works toolpath strategies. So there's a couple of different modules that are added this year. These are additional modules. Okay, so honestly, the modules we can come back to. Let's talk about what they're actually doing. So the first thing is multi-blade machining. There are two modules available for multi-blade machining. There's like a basic and an advanced, and it's the integration of these modules that'll allow to machine impellers or blisks very, very quickly and efficiently. Let's have a look. So here you can see the multi-blade machining module, and let me back this up a second. Pause it. So the blade machining module comes with 4 different tool paths. So you have blade roughing, you have hub finishing, you have blade finishing, and then you have the radius machining between the blades and the hub. Okay. All of this is 100% integrated inside of TopSolid. So we're not sending it outside to calculate or anything. And of course, it is integrated into the wonderful clean interface of TopSolid. So this is showing the simulation of the roughing algorithm. You can see we're using a tapered tool on that as well. And the idea here is it allows you to create the tool path that is needed. You can create it on one area or on all areas. It just depends on how you want to control it. Now this is showing the hub finishing. Okay. that is that. Now, let's take a look at the other algorithm that's been included by Module Works. It's called multi-axis pocketing. This command allows you to create 5-axis roughing routines on either convex or concave bottoms. You can do this with multiple passes using simple machining strategies, or you can use dynamic machining strategies similar to like a boost milling strategy on it. Let's have a look. So here, this is using a dynamic machining strategy. It is machining the bottom of that pocket in 5-axis to apply the roughing needed. If you zoom up, you can see that dynamic toolpath strategy. It's nibbling out corners just as you would expect a dynamic strategy to do. Now we can go over to the next one, and so forth. So a nice clean tool, very easy to use, very, very fast. Let's just win some time on this. There we go. So you can see how it simulates through. Alrighty. So that is the two commands that have been included by Module Works. All right, next. So those are some new products. Here's another new product inside of TopSolid'Cam. And this is TopSolid'Cam Simul and Cam Optimize. So TopSolid'Cam Simul and TopSolid'Cam Optimize, these are all new modules. This is G-code based machine simulation. The product that this is a product called Eureka. It's an Italian product. It is again being 100% integrated inside the TopSolid platform. There are different levels to this solution depending on what you need. If you only need G-code simulation for 3-axis milling, 2-axis simple lathes, then you would go with the Cam Simul M3 module, for example. If you need 5-axis continuous or single spindle machines, you would go with the Simul M5. If you need mill turn, Simul MT. If you want to optimize your G-code, and this is G-code optimization, then you would add the optimize. This would be on top of one of these. And then there's a Simul viewer that will allow you to create a viewer version of this for people on the shop floor, either to run on a PC or on a mobile device. Let's have a look. So TopSolid'Cam Simul, like I said, it's Eureka G-code simulation. It's integrated directly inside of TopSolid. Cam Simul equals what we call Eureka OEM. Okay. All the features available in Eureka to simulate, control, and verify the G-code generated by TopSolid in programming, whether you're in 2D, 3D, 4D, 5D milling, turning, mill turn, Swiss turn, or any type of machine kinematic. If we look at our first video, so here again, I'm showing you just a standard simulation inside of TopSolid, just so you see what's happening, okay? And there's another simulation showing the bottom there. Perfect. Now if we go to the TopSolid'Cam Simul, we hit our play button, it's now going to load TopSolid'Cam Simul. Again, you can notice we're still inside of TopSolid, but now we're doing G-code based simulation. So what's the difference? This is the code that's actually going to run on this machine. That's the difference. When we did the first simulation, that was based off of our CL data or our cutter location data. So while it's a very, very powerful machine simulation, it doesn't take into consideration specific cycles and what have you. What I'm doing here, by the way, and I apologize for the French in the video, I'm fast forwarding to a section in the G-code and telling it to simulate. So it is updating the stock in the background so that then we can simulate from that point forward in the foreground. You can see that was really, really fast to get that done. Okay, let's take another sample. So in this next sample, here we have a simple little B-axis mill turn machine. So I see a question pop up. How does it get the G-code? Yes, it automatically runs your post processor in the background. You just don't see it. So now we're running the G-code simulation. It's actually posting. When you click simulate, it actually post processes, loads that posted code into the simulator, loads your machine def, loads everything into the environment. Then you can play. So here is the program viewer, and we can watch this thing play. There we go. Now, while this is simulating, some people may ask, why do we have G-code simulation if we already have machine simulation inside of TopSolid? They all have their benefits. G-code simulation is a great final simulation to run prior to hitting cycle start on the machine. Okay, it is the final step. It's the last thing you could possibly check before you hit go. Machine simulation during the programming process is important as well because you can check for collisions initially, you can check for over travels initially. There's a lot of wonderful things that you can be informed on, plus the visualization of it during the programming process. So depending on the types of parts you're producing, maybe the cost of the material being produced on, or the cost of the machines, it may be worth adding a G-code simulation just for an added level of security. But as I was speaking, you can see that you have the simulation on the B-axis mill turn machine running. Alrighty. Now let's look at TopSolid'Cam Optimize and Viewer. Cam Optimize equals a product called Kronos. Kronos is the G-code optimizer that's available by Eureka. It will be available, we're expecting to release it on the 7.15 platform as of SP4. SP3 is going to be released, I believe, this week. So SP4 figure about 4 weeks, 6 weeks, something like that. Okay, but it's a post-processing process to optimize machining times of G-code. Okay, then you have the export to viewer. That is expected to be released in SP4 as well. You can save a simulation and export it to a PC viewer or mobile app. Viewers are provided by Eureka and available for free download from their website. So there's the website for that. Of course, if you guys buy this module, we will walk you through all this process. We can have a quick look at an optimization. So this is the standalone Eureka product we're showing right now. But it's running through the simulation and it's working to optimize everything, eliminate unnecessary movements, maybe change some rapid levels. It's doing what it can to fully optimize the toolpath. And then after that, it is showing you what it was able to optimize and then what the total optimization has saved you on the optimized code. Alrighty. So that is TopSolid'Cam Simul. Let's keep on going through the new features. I see a bunch of questions popping up there, and I know Joe is trying to answer them as much as he can. We'll go through whatever's left at the end of the presentation. Okay, so we've talked about Boostmilling, we've talked about Module Works, we've talked about TopSolid'Cam Simul. Let's talk the world of Swiss Turn. So with Swiss Turn, we're going to first talk about the roadmap of this product. So TopSolid'Cam Swiss Turn, as of 7.15, we'll go into here. One of the new features is to handle tool indexing optimization. Change tool on same position with multiple tool holders. So you see you have a B-axis head here, right? And it's got like a turret on it as well. So kind of a crazy example, but that's now supported. If we look to 7.16, so next year's version, one of the things coming next year is going to be parting off with Y-axis. And okay, we're showing this under Swiss Turn because this is where we see these used mostly, but of course, all of these machining operations, if your machine supports them, you can still apply them on there. Okay, so starting off with y-axis is coming. And then I know a few of you have emailed me recently about this type of turning, high dynamic turning. That's coming next year as well. Okay. We look to 717. There's a couple of big things that we're working on. The first thing is axes shared between channels. There's a few types of machines out there where you have to share an axis between different channels, which makes programming interesting. So the path will be divided and distributed among several channels and synchronized as well. We're going to be simulating the part support with subspindle. So you can machine this way today, but unfortunately you won't see the subspindle spinning or the main spindle spinning, depending on what you're driving by. So in the future, we will simulate both so that you will be more confident in what you're programming. G-code preview with synchronization, that's coming. And then we're working towards controlling specific functions of the machine. So not just that we're going to support specific functions of the machine, but we want to simulate them as well, so that if there's something specific your machine does, we want to show that, okay, it's going to move this channel to here, and then this is going to happen. We want to support these specific functions. And then beyond that, there's some other things that we're working towards adding. And, right now these are slated for, a few years in the future, but depending on demand, maybe they get moved around. Thread whirling is something that we're working towards. Oops, pardon me. Polygoning. I don't know if you've ever seen this type of process. It's pretty neat, but we'll work towards adding that as well. Gear hobbing will be coming as well. You can already do this with virtual jogs, but we're going to add a function specifically to support it. And then support of turning spinning tools with your B-axis. Okay, so that's the roadmap for that. Let's take a look at a couple of other items for where Swiss turn is inside of 7.15. So as of 7.15, Swiss turn is officially its own module. So I believe you have to have a license of turn as well with it. In order to use any of these post processors, you must have the Swiss turn module. These are the first 4 bases that we've worked on. Okay, so Citizen A20, A32, a Citizen M16, M32, a Tsugami, and a DMG Sprint. So these bases have been made and are working well on these machines. We've added some partnerships with Tornos and Citizen, Citizen and Miano, I should say, as well. For Star, Tsugami, DMG Mori, and Xtrab, we're working on those as well. So we're working diligently to really bring Swiss to the market as much as possible. Okay, so that's Swiss machining. Now, new product number 3. Okay, actually number 4 technically, because we added boost turning over here, 2 different module works, algorithms over here, G-code simulation over here, and now TopSolid ShopFloor Cam. So TopSolid ShopFloor Cam, okay, this is just to illustrate that it's its own module, because it's really its own software. Okay, let's learn about what it is. So TopSolid ShopFloor Cam, the goal is to give operators on the floor a tool that allows them to access TopSolid information in an interesting way. Okay, so TopSolid ShopFloor Cam allows a machine operator to access this data, first of all, based on having the right TopSolid rights provided to him by the TopSolid administrator. They allows them to open, consult, simulate, and verify any of the machining programs made in the production engineering office, but directly on the workshop near the machine. You can adjust items within the toolpath as well. So not all items, some items, and it's up to the manager in the production office to decide what items the people on the floor have access to modify. They could modify feeds and speeds. They could modify depth of cuts in some cases, or step overs in some cases. Again, not everything's modifiable. Okay. The user interface the user interface is very, very much the same as TopSolid'Cam. However, it has been simplified and compatible with touchscreens. Now, we want to point out, we say the word touchscreens, we don't mean cheap computers. Okay, we don't mean cheap tablets. It's still got to be a relatively powerful PC because it's still doing calculations. Okay, doesn't have to be a workhorse, but it can't be a cheap computer either. Secure connection to the PDM server is part of this. It's part of the PDM environment. It's going to access it with PDM user rights. Okay, and then this allows you to facilitate exchanges between the workshop and the production engineering office more seamlessly. Let's keep going. Let's have our first look. So here we're showing that we're logging in with to the PDM server. We're in standard TopSolid right now, and I'm just showing you a plate. Okay, some little sample. These are the parts that have been machined inside of TopSolid. You can see the simulation. It's wonderful. And then from there, we're going into ShopFloor Cam to show you what the rights are. So we can go in there. You can choose from that list what user you want to use. Okay, and then what rights they have as far as inside the environment. What rights do they have to modify, post-process, so forth, so on. So now we're in TopSolid ShopFloor Cam. We've logged on with the right credentials. You see your recent documents down below. You see that you have a search right there, so you can search for the project or the part that you're looking for. From there, you can decide to either modify or open the document as a copy. Okay? Why would you open it as a copy? Because maybe you don't want to modify the one that the engineering office did, but you know you're going to tweak some things here. This way, it's a copy. You're not affecting them. Or you can open and modify the one they have. That's up to you guys to determine what works for your organization. Down here, you can see we're showing some simplified tools for controlling visualization. On the right here, you see larger icons, again, optimized for touchscreens. Everything, by the way, is single click on this. You don't have to double click, right click, go into a menu. It's just click and go. Again, the idea is to simplify user experience out on the shop floor. So if we want to go see the NC Operations Manager, there you go. You can see that simplified as well. You do have a right click menu there if you want. You can also left click on icons to do specific things. There's your machine simulation. I see a question pop up there. Can this be put on a machine control? The answer is sure, why not, provided that machine control is running Windows. If it's got Windows 10 on it, why not throw it on there? If it's some kind of other operating system, then no. You'd have to put another PC out there. All right. So here you can notice that we're changing the tool that's being used, changing cutting conditions slightly. You can see some options are grayed out in here. Some options are lit up, again, based on user preference. What are the things that can be changed? Make our change, recalculate, and off we go. What's interesting here is, and where this might be used, maybe you're doing a huge production run. You get your first order of material in, you're running, everything works great, and then you get your next order of material in, things are running a little harder, so you want to slow down the feeds and speeds, maybe change depth of cuts. This is something an operator should be able to do. You don't need to go back to the front office to do this work. Okay? This last thing that was showing, by the way, while I was talking, was we took our modification, we checked it in this way, and you see it says shop floor on it. This way, the front office knows, okay, this was modified by the front office. Okay? Now, let's keep on going. All right. Lastly, we're going to get into some of the key new improvements inside of TopSolid'Cam for 7.15. Again, broad overview day today, so I look forward to seeing you guys all in the in-depth webinars coming up the rest of this week. Let's start with drilling. So, analysis of drilling in cylinders has become much, much more user-friendly. And more efficient. You can now analyze cylinders based on other geometric conditions. So based on a direction, for example, I want to analyze cylinders based on that face, based on that direction. So you can see it just found just those holes to analyze. Okay. Toolpath optimization. The whole idea here is to be able to optimize your toolpath to save time in machining, improve your productivity. So again, the software is looking to optimize all motion that it can with regards to drillings. I have an entire webinar about drillings, I think first off, when we start into CAM later this week. So I look forward to, again, going in depth into these things with you then. But let's have a quick look. So if we go to Analyze, here's all the drillings. So drillings plus tappings or just drillings. Okay, and there you go. There's all the drillings done, lickety split. Do you notice all of the centering that was done and optimized? So now we're optimizing everything. And you see how the motion has changed. Let's go here, optimize similar operations, do the same thing with those. So it's an optimization specifically for drillings, even if they're not from the same operation set. It's just to keep your motion to the minimal motion possible. Okay? Perfect. Next, breaking edges milling. So we've made some changes to the breaking edges command as well to make it more accurate on its edge search. Breaking edge milling will be maximized while guaranteeing the best cut for the tool. Machining feature analysis. Being able to choose an analysis direction is important, as well as detecting what a through pocket is. Okay. Also, we've worked on reducing the scan time of this. Now we'll go to here. So in 3D milling, some of you may be excited to hear this. We now officially fully support Highfeed cutters. Okay. Take into account the actual shape of the insert for more precision and maximizing the material to be machined. So with regards to this, and we'll touch on this more in depth again during the week, we support Highfeed cutters. These Highfeed cutters have interesting insert shapes, right? You have to define this type of cutter. We have no generics for this because there's too many variations out there. So you'll have to download or draw up your cutter, but now it can be supported with everywhere these types of cutters can be supported. Okay. Another optimization is to divide toolpath by tool length. So you have a very, very deep part, right? And we want to allow you to avoid having to machine at all with a very long tool. So we want to optimize all of that. So let's have a look. So first off, here's the toolpath, that original roughing, right? And you can see lots of collisions happening because, well, we chose a stubby tool. So we're going to click OK there after we turn on tool holder management. So now let's go in as far as that tool could reach. So now let's go to optimize and divide toolpath by tool lengths. And we want to use these tools. So yes, you would predefine these tools, or you can define them right there, but you click OK, and now it's going to start dividing up these tools, or that tool path, by each of those tools with different tool lengths. And the whole idea is to go as far as that tool can reach. And yes, it's even taken into consideration the back angles on the shanks of the tool. Alrighty, what's next? So 4-axis radial milling, many improvements in 4-axis radial machining. Much more user-friendly, simpler, faster. Oop, I thought we had a video. You can see we have the boost milling in there. Oh, apparently I don't have a video, sorry. Let's go to turning. This one's actually really cool. Customize stock to leave allows you to create your own custom turning profile inside of TopSolid'Cam to allow for custom stock to leave. Maybe you're leaving a certain amount of stock for grinding later, who knows, or you're just leaving a certain amount of stock because you're sending the part out for stress relief, then you're gonna come back and turn it again. But basically you have the control now to do whatever you need directly in your turning profiles. Another new function, machining function, shows up this year. Some of you may have been waiting for this. You now have the ability to do broaching via a specific function called broaching. Okay, let's have a look. So we have a part. If we go down to others here, you see a new command called broaching. Start by picking a tool. There is a generic tool available for this, or you can download and use a wizard to have a more accurate tool. When we choose the geometry, we want to machine those faces. The lead direction is that. Go into your settings and you can control how you want this to machine. First of all, is it the part that's indexing or is it the tool that's indexing? It's important when you're broaching. We'll say it's the part in this case. Then you have your depth of cuts. You have your exit distance for extensions if you need. And then there you go. That's showing the part indexing. If we show the tool indexing, go ahead and generate, and we simulate. Notice it's the tool now that's rotating, not the part. Now it's the part that's rotating. So again, you have the choice. Perfect. Let's keep going. Come down to here. Okay, so there's a new analysis mode for drilling and for end milling. One method is sufficient and will work regardless of the source of the part to be machined. Okay, again, for those of you that were in my webinar this morning, we're talking about machining feature recognition, okay, and passing that along to CAM. Probably, I think one of the more interesting new commands is the ability to copy paste in the same document. Now, this is different than drag and drop, okay? So drag and drop of Toolpath we've had since day one. That's awesome. I'm talking copying and pasting multiple operations, and when you do, it automatically asks you for the new destination faces. This is the way we do it when you're copying an operation plan from one CAM file to another CAM file, but now we're making it so that you can do it within the same document even, okay? So let's have a look. So we got a bunch of toolpath here, right? Yes, you can drag and drop. That's fantastic. And then you can go around and you can do whatever. This is what you're used to seeing. But what if we did it another way? What if you just copied and then pasted? And now here, you just select the faces of the geometry you want to apply it to, and it is applying all of those remachinings to those operations, or not remachinings, all those same machinings, but to the new geometries. So just a little bit faster, and off you go. Done. Okay, and just a simulation showing the end of this. Okay, last point of this webinar, I believe. Workshop documents, automatic generation of tool views. Okay, you can communicate communication even easier on the workshop. And then the CAD for CAM we talked about. If you were in this webinar earlier this morning in the design webinar to allow you to create multi-intersecting curves quickly. Again, this is being on multiple pieces of geometry at once to simplify it into a single surface, to simplify maybe complex 5-axis machining, even 3-axis machining. You could be doing this regardless of whether the surface geometry you're replacing is clean or maybe it's garbage geometry. There's lots of reasons for it. Okay, so if we take a look at this, so we're going to go do this machining. We're using sweeping, right? And now we're going to go ahead and create our profiles. Then we're going to go ahead and create our fit surface. We want to close it, of course. And then if we go back to sweeping this time and we choose that new surface, you're getting everything in one shot, and it's super easy to control. Let's do the same thing over here. So we're driving it by those guides. Make our fitting surface on it. And then again, we can make our sweeping on it. Super clean, super simple. And we'll show one more sample of it. So we're going to do it on all these faces. Again, make that fitted surface. Extend it a little bit at the beginning and at the end. And again, perfect toolpath blending it down. Okay, and of course, for those of you familiar with the sweeping command in CAM, you can of course project that toolpath if you need to. Use it for 5-axis, use it for 4-axis, go crazy with it. Perfect. Okay, so I believe, there we go. I believe that's it for today. I'm going to take a peek at some of these questions, see if there's anything I can give any additional information on. I am pleased that there are so many questions out there. Alrighty. Let's see.
There were 3 specifics to the Eureka and the Cam Simul.
Okay.
So,
All right, let me look in. So how much does a Simul package cost? Between $1 and $1 million. If your first and last name's initials are MM, it's $1 million. No, the cost varies. There is different product levels. I want to say, and again, it's a new module for us, so I don't know that I have all the pricing memorized like I have the rest of the product. So I want to say you start somewhere around the $4,000 range. All in, if you bought a complete full license of everything, you'd be up in the $20,000 range, somewhere in there. With the Eureka product or with TopSolid'Cam Simul product, you will need to get a reverse post processor and machine definition with it as well. So those have to be created. And then for Optimize, I don't know what is involved in Optimize yet because it's not yet released, so they don't give it to me yet. So we'll go from there. How does Eureka's Optimize compare to Verica? You know, I don't know the answer to that one yet either, but I'll tell you what, I will contact my Eureka guy and I will get some information and we'll share that information to everyone that was here today. So, but I need to modify my current machine definitions to work properly with Eureka code modules. Okay, so with the TopSolid'Cam Simul, you would create, or we would create machine definitions for you. I don't know if the machine definition creation is open to end users or not yet. As soon as I know that, I'll share that with you guys. But we'd create a machine definition for you, and it's called a reverse post processor because it's reading G code into their system to act like a controller, in fact. Okay, so there's that. TopSolid's parties. I don't know. All right, cool. Is there anything else, Joe, that you weren't able to answer?
Other than I answered Mr. John backwards on the NC civil question. So I think that was it.
Yeah. So, okay, cool. If does anyone else have any questions at this moment? Otherwise, I will say thank you for your attendance today and look forward to seeing you all in tomorrow's webinars. Awesome. I don't see any other questions coming up. So thanks, guys. Have a great afternoon.